This video is on transmissometers, or measuring the transparency of water or air. In history, we used to use these white and black discs, drop them into the water to see how deep we could see them. That gave us the turbidity or the transparency of the water. And we can do similar things with dusty or smoky air. But now in the 21st century or 2026, we have some sensors that we can use that are very helpful in determining the transparency of air using a transmissometer. Now, a transmissometer is a unique device. It's an instrumentation. It's not a word that you would use at the dinner table unless your table is filled with engineers. However, a transmissometer is a real-world 2026 term for an instrument. Now, to describe a transmissometer, I'll go through the elements here. You need a stable light source, a measurement zone, and a sensor. In this case, we have a tube, but it can be anything, even open air. There's some real-world math. One is called the Beer-Lambert law, where if you know your path length, you can determine your extinction coefficient. So the dimensions of your measurement zone, being the diameter of the beam and the length of the beam, are important to your math. Then you have the sensor, and I'm using a TCS 34725 and an OPT 4048 as light sensors. I also treat my LED very carefully in the electrical supply. I limit the current and expect that light source to be the same intensity and color every time I look at it. When you use a transmissometer, you'll get changes over time, and you need to keep a clock going so that you can measure the changes over time. When we talk about setting up and calibrating a transmissometer, there's a couple of things that you can do. One is a dark zero, using your dark zero for calibration. I don't do this because I'm using the zero at the bright light. However, I didn't want to leave it out of this video. When you start building a transmissometer, you'll find that there is some problems. Most of mine are shielded. The octo-rings are shielded. However, I'm working on a longbow that is not shielded, and you have to come up with some methods for compensating for the sunlight. I want to measure rain. I want to measure fog. I want to measure high humidity. And I've got some techniques, but you have to make the system stable otherwise, so you know that your medium is what you're measuring and not other things. So flicker is one thing. If it's not aligned, you have to have good precision current control on your light source. You have to have a good sensor with multiple readings and averaging those readings. To get it to work requires a lot of work to make it work for you, to make it work so that it's not creating a lot of strange data. When you're setting up a transmissometer, you're going to have to deal with alignment. And the smaller they are, the easier they are to align. The materials you use, they're heating up like a chimney, I didn't want to use sheet metal because it would change shape. I used rigid aluminum. And the longer you get, you have to make sure things stay in line. For example, if it moves during your measurement period, it's going to change your data, and you want to be able to say, hey, everything stayed aligned during my sampling period. Therefore, the only change is in the air or water in between the two measurement points. Transmissometers have been used for decades. It's not a term you use often. However, if you want to measure smoke, if you want to measure fog, you can use a transmissometer. I was building these in the 1980s, and I was using a photoresistor. Now, a photoresistor is not nearly as quality of sensor as the OPT 4048 or the TCS 34725. These sensors allow you to measure very fine light intensity details and color changes. And this is very useful for modern day environmental measuring. I will show you now some photos of 2 transmissometers that I'm working on. This is an octoring. This octoring went to the University of Berkeley for 2 years. I don't think it was actually used there. I'm using it now. This one has been on the chimney for 35 days, transmitting data the whole time, and it is working very well. I would say this is a good example of a shielded transmissometer. It only measures what's in the circle in the center, or the smoke coming out of it, or lack of smoke. Right now, it's running at 0 opacity. You can't see anything coming out of it. I don't have a fire in the wood stove. However, this is a good example of a transmissometer that is shielded from the sun and is rigid and maintains all the properties of a transmissometer. This is a longbow. It's a 3-meter, 11-foot long, unshielded transmissometer. You can see the light source in the back and then the sensor. I use a baffle to try to eliminate some of the noise from just ambient light. I've been testing this over the last year with the TCS 34725 sensor, and I just got the OPT 4048 sensor working on it, and I'm looking at the results right now to determine whether or not this is working and useful. I'll probably have to use some digital filtering on it. However, it's transmitting light, receiving light, and we'll let it go through a few daylight cycles to figure out if we can take the background noise out of it. This is our lesson on transmissometers. You can use it at your dinner table now if you got engineers seated there.